Hey guys, and welcome back to my CCNA 200-301 course. Patrice is here, and in this video we're going to talk about dynamic ARP inspection and how you can leverage it to protect your network. Are you ready? Let's get started. You might have heard about man-in-the-middle attacks, or MITM for short. Man-in-the-middle attack simply means that someone sits between you and a destination and intercepts or sniffs your traffic. And so they will be having one copy of the traffic that you're sending from your computer or any source to any destination. And that can include very critical data like your credit card information, usernames and passwords, etc. Man-in-the-middle attacks can happen in different scenarios or different types of networks, but our focus today is how this can happen inside local area networks and how we can prevent them using DAI or dynamic ARP inspection. Before diving into DAI, let's review the ARP process once again. For example, when your computer has an IP address something 192.168.1. something and the gateway set on the computer is 192.168.1.1, and that computer wants to talk to the outside network, for example, wants to talk to an internet service whatsoever. So it's out of my scope and out of my LAN subnet, so I need someone to take me to that, and that is my gateway, which is 192.168.1.1, for example. And the first thing is, okay, I know who is my gateway, but to be able to reach out to that IP address in the local area network, first, I need to figure out what is the MAC address for 192.168.1.1. And how do I do that? By sending ARP requests. And these ARP requests are broadcast messages, so everyone will hear it. But the destination who has the 192.168.1.1 address will respond through ARP replies and says that, hey, I'm 192.168.1.1 and here is my MAC address. So ARP process will let the source know that this is the destination MAC address for that IP address. And so that source will put the destination MAC address in the field and send the traffic to the switch, and switch will send it to the destination. This is the normal ARP process, but in some situations, like for example, when a MAC address changes on a device will send a specific ARP reply, which is called gratuitous ARP, which means that no one requests that ARP and no one asks for your MAC address, but you send it deliberately by yourself and send it to everyone and let everyone know that this is my MAC address. And this is called gratuitous ARP because you don't have any ARP requests, but you send the ARP replies without the requests. Hackers can take advantage of this process and send a gratuitous ARP to all devices in the network and spoof the gateway MAC address, for example, or any destination they want to intercept the traffic. In this scenario, the gateway address, and send a gratuitous ARP to everyone and hey, I'm 192.168.1.1 and here is my MAC address. And switch will put that MAC address, if you don't have the dynamic ARP inspection configured on that switch will put that MAC address as the destination interface for that MAC address, and from that moment on, any traffic destined to 192.168.1.1 first will reach out to the hacker's computer, and hacker will relay that traffic to the gateway itself. And so it will intercept all traffic from all sources destined to that gateway, which can be very critical data, including credit card information, username and password, etc., etc. Now let's see how DAI can help us to prevent these types of attacks. Like DHCP snooping, when you configure DAI for a specific VLAN, all interfaces by default will be untrusted. Unless, for example, for an interface or interfaces that are connected to upstream switches, you explicitly define them as trusted interfaces. And when you configure DAI, DAI will look into two things. First of all, DHCP snooping binding table. So if you want to use that, you have to configure DHCP snooping first and then DAR can use or can leverage the DHCP snooping binding table to check the status of the IP addresses and MAC addresses. And also you can configure an ARP ACL, which is useful when you have end hosts or any devices that are connected to that switch and they have static IP addresses and their IP address won't change. Anyway, switch will look into both of them. And both of these two things will have same information. Which MAC address X, for example, is connected to, actually has the IP address of Y, and it is connected to interface Z. So if a hacker with IP address, for example, 192.168.1.10 that is coming from DHCP tries to pretend or send an ARP reply or gratuitous ARP and say, hey, I am 192.168.1.1 and this is my MAC address, switch will check these two things or these two tables and see that this IP address does not correlate with this MAC address and it is not connected to that specific interface. So there's no any match entry for that ARP reply, and so it will discard that ARP reply from your hacker. And so the hacker cannot spoof any destination MAC address like the gateway address we spoke about. Now let's see how we can configure dynamic ARP inspection on our Cisco switches. Our scenario is like the previous video about the DHCP snooping. We have our switch that has DHCP snooping configured on it. We have the VPC, a PC that is connected to the switch, and also a DHCP server, which is a router. Like DHCP snooping, when you want to configure DAI, you have to configure it globally on specific interfaces. So we go to global configuration mode and we say IP ARP inspection and then VLAN, and you can specify one VLAN or range of VLANs. And if you need to configure on VLANs that are not continuous, you can use this approach. For example, 1, 3 to 5, 7, 9 to 11. So it will configure on VLAN 1, VLAN 3 to 5, not VLAN 6, and then VLAN 7, not VLAN 8 again, and then on VLANs 9 to 11. I have only one VLAN on this switch, so I say IP ARP inspection VLAN 1. And like DHCP snooping, if you want to configure a specific interface to be a trusted interface, you have to go to that interface or range of interfaces. For me, it's just one interface, gig 00. I just want to show you how you can do that, but you may not want to configure a DHCP connected interface as a trusted interface. But anyway, let's assume that this is an upstream interface to another switch. So we say IP ARP inspection, and then trust. And with this command, you can make gig 00 a trusted interface for dynamic ARP inspection. I tried a ping from this PC to this DHCP server to trigger an ARP process. So before going to checking the ARP inspection situation, I want to show you show IP DHCP snooping binding. We saw this in the previous video, but just to double check, you can see that there is an entry for this MAC address, which is my PC MAC address, and the IP address associated to that MAC address is 10.0.0.11, and it is in VLAN 1, and the interface is gigabit Ethernet 0/1. So now, if my PC tries to pretend it has another IP address, for example, 192.168, 10.0.0.1, for example, which is our DHCP server, for example, and sends an ARP reply and tells the switch, hey switch, I am 10.0.0.1 and this is my MAC address. Switch will check this DHCP snooping table and see that no, this is not the entry for that MAC address, and there is no any association between that MAC address and that IP address and on that interface, so it will discard that ARP reply. To check the status of ARP inspection, you say show IP ARP inspection, and this will show you a few things. The first of all, which VLAN has IP ARP inspection enabled on it, and what is the status? It is active. And you can see that in VLAN 1, you had inspected 5 ARP replies or packets, and they all forwarded, and there wasn't any drops. And if you have some drops, you can figure out if those drops coming from checking the DHCP snooping binding table, or it is coming from the ARP ACL you have configured on your switch. And as you can see here, there are some extra options you can configure on your DHCP snooping to validate the source MAC address with the hardware MAC address, and also IP address, and also destination MAC address with the hardware address. So it gives you further inspection on your devices. So if you want to configure that, you go to global configuration mode and you say IP ARP Inspection, and then you can say you validate and say validate destination MAC address, validate IP, and validate source MAC address. So you add extra layers of inspection for your traffic. Like DHCP snooping, this is another thing that hackers can leverage to launch another type of attack, which is called denial of service. So they can bombard your switch with a lot of ARP replies, and since this inspection requires CPU cycles, this will increase the CPU usage on your switch and can take it out of your network, and it cannot do its normal job, so your network will collapse. So again, like DHCP snooping, you can configure rate limits on interfaces. So for example, if I go to interface gig 0, I can say IP ARP inspection, and then I can limit the traffic. So here you have two options: limit none, which is basically saying that we don't want to have any limit on this one, but you can say rate and give it a limit between this number. And as you can see, again, this is packets per second. Unlike DHCP snooping, you don't have to configure this. Why? Because DAI has 15 packets per second default value, and it enforces this value on all interfaces in that VLAN you have configured dynamic ARP inspection on. So you don't have to do this unless you want to change that default value from 15 to whatever is more suitable for your network. And also in DAI, you can configure a burst interval as well. What does it mean? It means that you rate limit, for example, 15 by default, and you say that 15 ARP messages are allowed on this interface per 1 second. 1 second is also a default value. So in 1 second, only 15 ARP packets will be allowed on that specific interface. And if you want to change this, you can continue and configure this value. For example, you can say 10 and then burst, and then you mention on which interval, which is based on the number of seconds. For example, and on this switch, it can be between 1 to 15. So for example, if I say 3, this means that on this specific interface, I will allow 10 ARP messages every 3 seconds. So in this way, you can control the number of ARP messages on that specific interface, or you can select multiple interfaces for this setting, obviously. If any interface tries to exceed the number of allowed ARP traffic, I mean going beyond that rate limit you configured on that interface, switch will put that interface in error disabled mode and will shut it down. So if you want, like any other situation, any other security or other features that put an interface in error disabled mode, if you want to bring that interface back up, you have to manually shut it down and bring it back up with no shutdown. And like other features, you can configure this to happen automatically via error recovery situation. So again, in global configuration mode, we say error disable, and then recovery, and then cause. This time the cause is ARP inspection, and then you press enter. So if any breaches happen with regards to ARP inspection rate limit, it will bring that back up after a few number of seconds, again, that you configure it globally on the switch. But this timer we configure, and we configured it in the previous video as well, will be applying on all of these recovery situations. So there is no any specific interval for a specific cause. So bear in mind that this will apply to all of the error disable recovery you configure. So error disable, recovery, and then interval, and you say, for example, 30 seconds. And this will be applying on all of the error disable recovery causes you configured on your switches. The last show command I want to tell you here is show IP ARP inspection and then statistics. As the name shows that, this will show you the statistics of ARP inspection on your device, and you can figure out how many forwarded, how many drop, what was the cause of the drop, was it coming from DHCP snooping binding, or it comes from the ACL drops. And as you can see, this information are visible via show IP ARP inspection as well. Alright guys, this was our today's video. We covered the last part of exam topic 5.7, and we configured and verified dynamic ARP inspection. In the upcoming video, we'll be configuring a WLAN with WPA2 pre-shared key. I wish you enjoyed today's video, and see you in the next ones.